So, what if you could know a student was struggling way before their final exams? I mean, really, get a heads up. Well, today we are going to dive into exactly that, how machine learning can build a kind of crystal ball, an early warning system that gives teachers a chance to step in when it is actually matters the most. So, here it is, the big question, right? Can a computer, just by looking at some pretty simple behaviors, tell if a student is in trouble, maybe even before their teachers can? The answer, well, it might just surprise you. Let's walk through how a system like this actually gets built from the ground up. Alright, here's our game plan. We will kick things off with the challenge we are trying to solve. Then, we'll look at the ingredients, obviously, the data. After that, we will go hunting for clues and patterns. From there, we will build not just one, but two predictive models. And then, we will see how it all comes together. From the code to an actual classroom scenario. So, let's set the stage here. Look, every teacher wants to help every single student succeed, right? But think about a busy classroom. It is just so tough to spot the student who is quietly falling behind until bam, a bad test score makes it painfully obvious. And by then, honestly, it can feel like it is too late to catch up. What they really need is a tool that's proactive, not just reactive. And that is exactly what we are going to do here. Think of this whole thing as a step by step how to guide. We are literally going to walk through the process of creating system that can flag at-risk students super early, giving teachers a data-driven heads up. So, how do you build a crystal ball? Well, you start with the right ingredients, and in the world of machine learning, just data truth. The prediction, the insights, they are only ever as good as the raw information you feed the machine. It's the bedrock. Everything else gets built on top of this. And for this project, we are having a massive foundation. I mean, we are not talking about a few dozen students here. We are looking at a data set of 1 million anonymous records. That kind of scale, that's what allow the system to learn really solid patterns and make predictions you can actually rely on. Okay, now what's really interesting here is what we are actually measuring. It's not super complicated stuff. We are just looking at three key behaviors: how many hours a student studies on their own, how often they actually show up to class, and how engaged they are when they are there. And the whole goal is for the system to learn how these three things connect to the final outcome, their total score. Alright, so we have got the data. Now, the fun part begins, the discovery phase. Before we even ask a machine to start predicting the things, let's see if we can spot any obvious clues or patterns ourselves. Time to do a little detective work. Let's start with the most obvious question. Does hitting the books, does it actually make a difference? I mean, it seems like no-brainer, but let's see what a million data points have to say about it. Every single dot you see here, that's a student. And as the weekly study hours go up along the bottom, you can just watch the scores tend higher and higher. The relationship is, well, it's undeniable. And check this out. Here's that same data, but in a different and honestly even more dramatic view. This chart just lays it all out, doesn't it? It's not just a small difference, it's a massive one. Students who are considered safe, the ones who pass the course, they study an average of 17 hours a week. But the students who are at risk, just 6.6 hours. That's almost three times less. The data could not be any clearer on this. But here's the thing, it's not just about one single behavior. The data also shows that showing up consistently and actually participating in class discussions are also strongly linked to better grades. So, the key takeaway here is that it's combination of these positive habits that really lead to success. Okay, we found our clues. Now it's time to build our first predictive model. The process really starts by just getting the lay of the land. The system weighs through the data from about a million student records, and from that, it starts to see the pattern. For example, you can see here the distribution of study hours. Most students seem to fall somewhere in that 10 to 20 hours of a week range. Now, this is where the magic happens. We are going to start with what we call a score predictor, and its whole job is to try and guess the exact final grade a student is going to get. Now, we are using a model called a random forest regressor. I know that sounds super technical, but the idea behind it is actually pretty simple. Imagine you have a whole team of experts. Each one looks at the student data, makes their own little predictions, then this random forest just averages all of these opinions together to come up with one final super accurate estimate. It's like a wisdom of the crowds thing. So, how do we actually teach this team of experts? Well, first, we separate our behavioral data, the study hours, and all that from the final scores. Then we split it up. We give the model about 80% of the data to learn from. Think of that as the train set. It's like a big practice exam. And then we hold back the other 20%, the test set, to see how well it actually learned. That's the final exam the model has never seen before. So, how did it do in the final exam? Well, the model got what's called a R-square score of about 71%. Now, what that means in simple terms is that those three simple factors, study hours, attendance, and participation, can explain a pretty incredible 71% of why a student's final score is what it is. That's really powerful. Okay, predicting an exact score is pretty cool, but for a busy teacher, a specific number might be less useful than just a simple warning. And that's exactly why we built the second predictive model, the risk detector. Its only job is to raise a flag, a simple red flag, if a student looks like they are in trouble. And this slide really gets to the heart of the difference. The score predictor gives you all the details, but the risk detector, it gives you a clear signal to act. It's answer a really simple yes or no question. Does this student need my attention? And for an early warning system, that's often exactly what you need. So how good is it at making that call? Well, the overall accuracy is a very, very strong 84.5%. What that means is for every 100 students, the model correctly identifies their status, whether they are at risk or safe, about 85 times. That's pretty solid. But hold on, let's dig a little deeper because overall accuracy doesn't tell the whole story. The really crucial stuff is right here. Look at risk recall. It is at 87%. This means our system successfully catches 87% of all the students who are actually struggling. That is the number one or most important job of an early warning system, right? And then check out at risk precision. When the model does raise a flag and say, hey, this student is at risk, it's right 96% of the time. This is so important because it means we are finding the kids who need help without constantly bugging the teachers with false alarms. Okay, its performance is summed up in this chart, which has a kind of funny name. It's called a confusion matrix. So, this has all been about the theory and the numbers. Now, for the most important part, what does this actually look like for a teacher?
Let's take our system out of the code and put it right into the classroom. Alright, let's imagine a single hypothetical student. They are studying a decent amount, almost 11.6 hours a week. Their attendance is over 100%, which is pretty good, and their class participation is okay, a 8.2 out of 10. Now, on the surface, these numbers don't immediately scream trouble, do they? So, what does our system think? So we feed these number in and instantly we get our answer. The system predicts a final score of just under 79, and more importantly, the risk detector show the student is on the safe side. A teacher can see this in a split second and know they can focus their attention where it is needed the most. So we have built it a system that can look at a few simple behavior and predict how a student will do with really remarkable accuracy. It is basically a crystal ball for the classroom, and that leaves us with one final and crucial question. The challenge isn't about prediction anymore, it is about intervention. Now that we can see the future, what's the absolute best way to change it for the better?
That's it for today's video. The complete source code dataset and instructions are available on my GitHub. The link is in the video description. Thank you.